Hello and welcome everyone to today's webinar on autonomous database observability with Grafana. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to get hands-on and show you how to configure and use Prometheus and Grafana with your autonomous database to analyze and correlate metrics, logs, and tracing. We'll also be recording the session and the link to the recording will be sent to you via email the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Oracle Autonomous Database that you can access at the QR code there or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We'll also be checking the Zoom chat and Zoom Q&A areas throughout, and we'll open up for live Q&A after the demo. Today's webcast will be presented by Herman Viscuso, Director of Community Management. So without further ado, I will hand it over to Herman.
All right. So thank you, Tara, for that. I'm very, very glad to be here. Always, enjoy any session like this, especially because I'm surrounded by colleagues that are knowledgeable. Every time I talk to my mom about this, she doesn't get it at all. But you will get it, right? So I'm super happy to be here, and please feel free to ask questions and join our Slack channel if you have questions. So for those of you that never participated in a session with me, my name is Herman Viscuso, and I'm a member of the Autonomous Database team. And I've been running a series of webinars recently and writing blogs about observability in Autonomous Database. It's a topic that I really, really like. And I wanted to introduce you to a solution for a unified approach at observability that we built at Oracle. So kudos go to Paul Parkinson and collaborators for building such a great project. I really enjoyed, trying it out, working with it, etc. So my goal today is to leave you up and running with a unified observability solution over Grafana that you can later adapt to your needs. I really wanted to go through this step by step, but we will have to take a few shortcuts because you need to deploy the project, etc. But I'll be very clear about what I've already done, etc., etc. But this is going to be very hands-on. Okay. The project observes microservices backed by autonomous databases. In this case, two autonomous databases, an order and an inventory database. And if you want to follow along, you need to be at least in a fresh OCI free trial installation. And as long as you don't have a lot of resources already provisioned, it's kind of fresh, you will be able to follow along. Okay, so please do that if you feel comfortable. All right, so first of all, who is familiar with autonomous database? I would like hands if you have that functionality over there. Ever heard about autonomous database? I want to have this slide right here for those of you that are not familiar with this database service by Oracle. Okay, so Oracle Autonomous Database leverages the Oracle Converge database. You probably heard of Converge database. It's basically our support in Oracle for multiple data types, multiple workloads, etc. For example, you can store JSON and maybe you can query via relational means, So the Oracle Converge database, it's running on top of, on the cloud, on top of a great infrastructure called Exadata. For those of you who have never heard of it. So Exadata, in the case of the public cloud service, runs in the cloud, and it's the fastest database machine ever made, and you can provision it within OCI, which is great. But why do we call it autonomous? Because we have added a layer on top which provides self-tuning, self-securing, self-patching. It does a lot of the hard work for you. It does a lot of the DBA work for you, so you don't have to worry about that. So we think it's a great fit for developers specifically that maybe want to provision a test environment and a prod environment quickly as part of their DevOps, processes. So we think this is great. So it is the fusion of the best of database, cloud, and machine learning in the 21st century. Okay, so the example and the project that I'm going to show today is going to automatically deploy 2 autonomous databases. And as long as you are on the free trial, you'll be able to deploy them. And I think that the limit is right there. Okay. All right. So we are talking about observability. We're going to discuss observability. What's observability? So this whole movement around observability and defining the specific pillars about observability with metrics, logs, and traces started by a blog that the Twitter engineers created, and where they defined these pillars. Actually, the blog included a fourth pillar, which was alerting and visualization, but we can basically take that for granted because that's what we do once we are dealing with metrics, logging, tracing. We create alerts, we visualize in Grafana, etc. So not really a pillar, but these are the elements or the building blocks of any observability infrastructure or any observability tool. So you probably know what logs are. So that doesn't need a lot of explanation, right? Metrics, we are monitoring specific values for systems. So for example, database metrics, because we want to understand if we are within specific limits or if we have performance issues, et cetera, et cetera. And then we have tracing, which is more complex, but tracing gives us the ability to go across these different elements and basically be like a detective where we can go through a specific request and see what's exactly happening and go all the way through metrics or even up to the logs level, et cetera, et cetera. So the trace is more horizontal, okay? And it's something that is basically give us a very valuable information, but it's very contextual. It might be related to specific requests, for example. So as you can see, there's high volume for logging, there's low volume for metrics, okay? And tracing is right there in the middle. Now, observability is really hard. Nowadays, you could be dealing with architectures where you have VMs, where you have Kubernetes clusters, for example, where you have infrastructure like Exadata, like I mentioned before, where you have databases, right? And suppose that all of these elements, and not suppose, but actually they are generating metrics, right? And they are providing metrics to you that you need to monitor. You might need alerts, et cetera, et cetera. So if we have to go and be monitoring each one of these elements separately, right? That's a big mess, especially if we want to correlate what's going on. So suppose that we want to correlate what's happening to infrastructure, like Exadata, for example, just to what's happening at the query level on a specific database, right? So if we have everything separated, things become more difficult. So it is much better to have this unified view of observability where everything is aggregated, and that can be facilitated but in different means, right? One of the examples that I'm going to talk about today is unified observability framework or platform, and that is one way. But for example, another way could be having these elements, which you can see on the screen right now, which is VM containers or databases infrastructure within a single cloud. Like for example, you can have them within OCI, and as long as those elements are sending telemetry to a specific monitoring service, like the OCI monitoring service, you will be able to take a look at those in a unified way, right? But sometimes that's not the case. Sometimes you need to deploy in multiple clouds, hybrid cloud. Sometimes you have on-prem systems that also need to send telemetry. And sometimes you are dealing with multiple elements that are fundamentally different, and sending telemetry in different ways, okay? So this is a tough one to solve. Okay, just to be clear. Now, I mentioned that suppose that something happens at the hardware level, for example, we want to know what's happening at the database level. This is the infrastructure that is behind an autonomous database, and starts from the Exadata infrastructure on the top, which is bare metal, right? You can, if you go to OCI and you have enough money, you can actually provision an Exadata infrastructure. Then you will have to provision an autonomous VM cluster on top. So we are dealing with it at the cluster level right now. And now within the cluster, you would provision autonomous container databases. Autonomous is following the pluggable database model or architecture that you've seen before at Oracle, where you have these container databases that can host multiple pluggable databases, and which give you the ability to maybe do maintenance at the container level, so you don't have to deal with specific operations, specific things when you're dealing with PDBs. So we have autonomous container databases, and then inside the containers we have autonomous database instances, which is ADB1, ADB2, ADB3. Okay, so this is just so you know at how many levels we could be generating telemetry for autonomous databases and why this is important. Okay. All right. So I mentioned events, I mentioned metrics, et cetera, et cetera. What is the difference between events and versus metrics, for example? So this is an example of the events that we are emitting within autonomous database. For example, if you start the database, you can get an event, right? Suppose that you create a database or you change compartment, you can get an event. This is obviously asynchronous. These things are happening when the operation is happening, right? This is not being aggregated, etc. So this is ideal for, alarms or to wake up, some kind of process when something starts to happen, like for example, a backup started, something like that. But then we have other things that we are aggregating, which we call metrics, and this is more synchronous, where we collect, all these different metrics, like for example, CPU utilization, to give you an idea, that you can also use to create alarms and to monitor. But this is basically synchronous. We are collecting this periodically on a specific interval granularity, and we are aggregating these metrics. And in this case, what I'm showing you is the metrics that we are exporting. And the metrics that we are exporting, that autonomous database on dedicated infrastructure is exporting, it means that we are sending these metrics to the OCI monitoring service, right? And the OCI monitoring service is a great aggregator of these metrics, which would aggregate metrics from autonomous database, but also from all the other database services and all the other services that are not necessarily database related, okay? But it turns out there is a way to extract more metrics than the ones that you can see here that are being exported to OCI metrics. And I will go into that, okay? Now, enough of autonomous and how autonomous is exposing, metrics and events, etc. This is very useful. There are native tools that you can use to actually, tap into all of this. But this session is about Grafana, right? So what would be the, let's say, straightforward approach for you to do if you say, hey, I have an autonomous database, or I have maybe an Oracle database in the cloud, maybe another service, and I want to go to Grafana. And please raise your hands if you heard about Grafana before. I need to understand if you're familiar with Grafana. Okay, we have a good number there. Awesome. So for those of you that raise your hand, and if you were wondering how do I connect my Oracle database to Grafana, the typical approach that you would do is just go to the plugins and take a look at the plugins. As you know, you go to Grafana, there are multiple plugins or data sources that you can attach, and you would just type Oracle, and these three would show up, okay? You will get the Oracle database plugin built by the Grafana team, okay? You will get the OCI metrics plugin and the OCI logs plugin built by Oracle, okay? So the Oracle database plugin is it's commercial, it's closed source, you have to pay for it. It comes with Grafana Cloud Pro. It basically establishes a TCP connection between your Grafana instance and the database. So it has some security concerns, if you want, because it allows you to, over this TCP connection, runs a modified SQL. So you might want to limit the user that you are assigning here to actually be able to run SQL over the database. And it allows you to tap into performance views that I'm going to mention later. I'm going to tell you all about it. But the interesting part of this plugin is that since it allows you to run unmodified SQL, you might as well use it to extract business data, for example, not necessarily performance information, but you might extract anything that is within your tables, that you want to visualize within Grafana. So it's interesting. Now, then we have for performance, we have the OCI metrics plugin, and this is the service that I mentioned before within OCI that aggregates all the different metrics from multiple OCI services. And with these plugins, you can tap straight into that. So if you use this OCI metrics plugin, you would be able to tap straight into these metrics that I showed here, right, from autonomous. Obviously, all the other metrics from all the other services. But if you want, you can just go and get into these metrics, which are usually using 1 minute interval granularity, to give you an idea. In general, not all of them, but in general, most of them are using 1 minute interval granularity because these are exported and sent to the monitoring service, okay, and aggregated by the monitoring service. Similarly, there's a log logging service within OCI that is aggregating all the logs from all the multiple services, including autonomous databases, and you can tap into this OC logs plugin, okay, using Grafana. But we could use these plugins like metrics, but that would limit us to the exported metrics, and that would have no correlation with logs or traces. Okay, so it's basically just tapping into one specific thing that we want to use, right, and to visualize, but correlation would not be possible in this case, or you will have to do that kind of work. And this is one of the nice things about the solution I'm going to cover today. So a third option that you might find within Grafana is this, they added recently this Oracle DB integration for Grafana Cloud. And it's basically, if you have an on-prem system where you can install an agent, you can install this agent, and this agent will start sending telemetry to Grafana, okay? As you saw before, I'm saying this is not addressing the problem. So what is the problem and what is the solution, right? So the problem is that developers, if you probably saw my subtitle in the presentation, I said DevOps plus DataOps, right? So developers are using these very tools for debugging and performance tuning when it comes to the app and when it comes to the database. So there seems to be a mismatch between database observability tools and app observability tools. We're talking about DevOps versus DataOps. Well, this should be DevOps plus DataOps, you know? So this is basically the problem. The tools are good for a few things, you know, maybe for application performance monitoring. What if I want to just plug in my database and be able to correlate what's going on in the app to what's going on in the database? How can I make that, you know, connection there? And customers are inclined towards using open solutions, like open telemetry-based solution, Prometheus, Grafana, a lot of open source, etc. But that is today not very database friendly unless you start using the plugins, etc., etc. But we really need like a framework, you know, to be able to aggregate all of this and to be able to do this different correlations between what's happening within the app and what's happening in the database. So the solution is to use something like what I'm going to show today, which is a standards-based, is using the Cloud Native Computing Foundation Open Telemetry. For traces, is using Jaeger. I'm not sure if you heard about it. Please raise your hand if you heard about Jaeger for tracing. Let's see. Okay. A few. Okay. And so the solution is using Prometheus, which is a time series database, which is very friendly with Grafana. It's using Loki for logs and ultimately Grafana for the visualization. So we call this a unified observability framework or project. And this is what I'm going to talk about today, okay? So let's see some of the advantages and some of the benefits. So I think, and I'm not really sure about this, I should probably ask Paul Parkinson about this, but I think that this project started with something like this, which is monitoring transactional event queues within databases. You know that transactional event queues are a system to do persistent queues, you know, for events. It's kind of a Kafka replacement. You can basically do like a direct one-to-one replacement in many cases, but with the advantages of being really close to the database. You need a separate Kafka broker for that. So they wanted to monitor the queue and the queue rates of this solution using these events, right? So because when you put events in the queue, that queue might overrun, maybe you have too many, and then you need to dequeue, you know, and basically consume those events. And what if things are becoming difficult, you know, in terms of performance? So a great way to do this is to monitor what's going on with the queuing and the queuing rates, and that's metric right there that you need to monitor. But what if we want this to be very, let's say, container friendly, right? A very, very good approach would be to have an exporter of those metrics. And in this case, for this system, they use the Seth Miller Prometheus exporter. this is an open source project. This is not an Oracle project. It's an open source project by Seth Miller that you can find on the web. That's basically scrapping the database views and generating an exporter for Prometheus. So Prometheus, in turn, which is a time series database and is really friendly to Grafana and can be easily connected to Grafana, would do the scrapping of this exporter to actually get all the metrics. And in this case, we are talking about queuing and dequeuing. Okay, so as I said before, this is running within a Docker infrastructure, and even the Grafana instance is within a container. Okay, so the Grafana instance is inside, and it's basically incorporated into all of this. So this is probably the beginnings of Prometheus Grafana for Oracle, and I think that if we take a closer look at what Prometheus Grafana for Oracle is providing, the idea is to provide metrics, logs, and tracing in a microservice-friendly environment, and this is for developers running in Kubernetes environments. So everything is Kubernetes-based. And the goal is to highlight all the different performance metrics coming out of the database, but also be able to correlate that to specific things that are happening within the app. Okay, so we are talking about Prometheus for the metrics. We're talking about Jaeger for the tracing, and we're talking about Loki for the logs. Okay. So Grafana is the system that allows us to visualize everything. Now, how can you actually get this? How can you actually run this, right? So you have this as open source in GitHub. There you have the first link, but this is also available as a container image that you can actually go on and grab, okay? So what I've been working on is basically by cloning this repo here and working with that specific repo that we use for workshops, for live labs, etc., etc. Okay, but a picture says more than 1,000 words. So let's have a quick overlook at the architecture. Okay, so here we are. When we deploy this, we are monitoring 2 autonomous databases, but we could as well be monitoring any Oracle database with the solution. And this is thanks to a controller that I will mention later that we took from the Aura operator, but I will go into that later. So basically, we have a Kubernetes environment that it's allowing us to seamlessly connect to the Oracle database, and it's providing a set of exporters like tracing exporter, metrics exporters, and log exporters. Those are the 3 pillars that I mentioned around observability, and this is providing all 3 of them through different technologies. Like, for example, we have Jaeger for tracing, as I mentioned before. We have Prometheus for the metrics, and we have Prometheus and Grafana Loki for the logs, right? In this case, even this Grafana instance that you can see here in this graphic is running within the container. Okay, so everything is containerized. You can, of course, run it outside a container if you don't want to do that. But this project is set up so that you have great Terraform scripts that basically set up everything for you. And this is what I wanted to show you today. Okay, so use cases, troubleshooting of the database, but not necessarily the database, also of the microservices themselves that are supported by the database, okay? Because you can also do traces at the app level. You can do performance tuning, what's happening with this orders database that is not being able to ingest orders, in a reasonable time. Alerting, something is odd here, let's send an alert, let's do a trigger or something like that. And high availability and capacity plan, okay? All right, so before going further, let me mention that within Oracle databases, and this is also true for autonomous database, you have dynamic performance views, also known as $B views. Please raise your hand, those of you that heard about $B views before within Oracle databases. $B or GB views, okay? All right, I can see a lot of hands there, that's good. So for those of you that are not aware of this, you can access views within the database that are continuously updated. The contents is related primarily to performance. You can basically read them, but you cannot touch them in general, okay? If you are familiar with Oracle Enterprise Manager, this is what Oracle Enterprise Manager is using to show you this database instance metrics, for example. And for every dollar view, you have a corresponding GB dollar view, which stands for global. The G is for global. So basically allows you to retrieve the view of the instances within a real application cluster, right? So you will get the same columns that you get from regular view with an extra color called instance ID. So you get more information from GB dollar view, except that you will have to filter by instance, okay? And each one of these have their own set of columns. I have some examples there. These are all accessible from Autonomous Database, but these examples are GB active session history, GB persistent subscribers, which is good for transactional event queues, queuing and dequeuing, as I mentioned before, with our await chains, with our session. Each one of these, we have their own set of columns, okay, that you have to understand and learn if you want to tap into them and use them. And we will use them in this solution. So this solution is basically using these views to actually extract metrics information, but giving you the ability to just define those SQL queries that you want to run to actually extract specific metrics. So it's very flexible, and we will go into that. Okay, so I had to go, I went through part of the demo because the deployment of the demo takes 15 minutes. So the moment you type setup in order to set up this demo, it takes 15 minutes, and I did not want to just basically keep you waiting here for 15 minutes. But what I'm following here is the live lab, the great live lab by Paul Parkinson that you can access here in this short link in the top right. It's a step-by-step live lab. It's very self-explanatory. It's very straightforward. And what I did is I went to cloud.oracle.com. I created a free trial account. I think that I have $213 at this point in that account. So I am on the free trial. It's not special or anything like that. I created a compartment. I call it workshop. And I find this to be very useful because then if I want to destroy the resources for the workshop, I just can focus on destroying whatever is inside that compartment. So I recommend you do that. I created the compartment called workshop. You can call it whatever you want. Then I went into the Cloud Shell, and we're going to go and take a look at the Cloud Shell in a moment. It's basically a bash shell that you can access within OCI. You can access it in the top right of the OCI console. And in that Cloud Shell, I created a directory called GrabDish. Why GrabDish? Because this project for observability is using, as an example, a set of microservices that basically are mimicking an food ordering system, where you order something and then you have an inventory of food, et cetera, et cetera. Very simple. We have just a couple of microservices and a couple of databases, but it is a great, excuse or great example to have an app generating some information so that we can put in the database. Okay. So what I did is I cloned the repo here, coming straight from Paul's team. If you find issues with versions, or if you have a setup fail, something like that, and I'm not sure if this was fixed already, but you can clone my branch. In this branch, what I did is updated the Kubernetes version from 125.4 to 126.2, and that's it. Just a couple of files where I updated the Kubernetes version, so OCI does not complain that it's not the latest one. Okay. So if you run into setup fail, just go ahead and grab mine. That's open too. Then I did a source, microservices data and workshops, the OCI source. So this is basically getting us a whole bunch of variables that we need to basically, CD into directories and stuff like that. And then I just run setup. So this is mostly cloning repo and running setup. Okay, so it's not much more than that. When you run setup, the system asks you for a compartment OCID, and this is my workshop compartment right here, okay? Workshop compartment right here. And then the system asks you for your user OCID, which is available in the profile. You go to the top right profile, and you can get your code, your ID for your user. And then you need to provide a password. You need a password for the databases and a password for the UI. and I just provided the same password for both. I waited 15 minutes, and that's it. So I'm going to show the output here for the record. So you actually have a reference here in case you get stuck, right? Make the directory grab dish, cd grab dish. Here I do the sourcing of the environment variables, okay? Here, and I just did this today, like a few hours ago. And then I run the setup. Let me just find the setup. Where is it? Right here, okay? Run the setup right there. So as you can see, I was asked for the compartment OCID, and I just passed the OCID of my compartment. Then I was asked for the user OCID, and I passed that. As you can see, I was asked for the password for the databases, and then for the password for the UI. And I'm basically sending the same password for the sake of simplicity. And after I did that, I waited like for 15 minutes to give you an idea, 15 minutes, where this was auto-updating all the time. So basically refreshing. You have to touch it, and I got a setup completed. Once I got a setup completed, I basically went through the first part of the lab, okay, which is the setup. And we're going to go together live through the second part of the lab, because otherwise we won't have time, okay? But before doing that, I'm going to the second part, and we will do that right here within the Cloud Shell. And this is the Cloud Shell and where you access it, okay? So before doing that, let's take a closer look at what's really going on here, what we are doing. Let me go back to presenter view here. Okay. And let me stop on metrics. Remember, the system is exporting metrics, traces, and logs. Traces is by far the most complicated of the three, because if you want to correlate what's happening within the database, for example, to the app, you have to insert some information there, because the database as a standalone is not aware of the app, right? So traces are a little bit more complicated. That's why I left them traces are a little bit more complicated. That's why they are in the last part. But let's focus into metrics. So the idea here is to have customizable queries, such as the one that you can see here, that you can provide to this framework, right? And that can be translated into real tangible metrics that you can visualize within Grafana, okay? This is one example of a metric. For example, remember that I mentioned the transactional event queue system. Remember that I mentioned the queuing and the queuing system. So suppose that you are interested about the total number of subscribers for those queues within the database. And remember that transactional event queues is a feature that is within the database. So it is exposed within the database in terms of metrics, et cetera, et cetera. So you would just do a select. As you can see here, we're doing a select and asking for, total subscribers, basically count asterisk, from this $GB persistent subscribers views. And this is a standard $GB view that I already mentioned before, right? So suppose that you have a view that you are very familiar with, and you have a really interesting metric that you have right there. You can just provide the system with this type of metric, similar to this one, and automatically that metric will be exported, and you will be able to visualize it within Grafana. So that's the power of this framework of this solution. Okay, you are not limited to the examples of metrics that we are showing here, or to the examples of metrics that come within the database. Within the framework and the project, which is in GitHub. There are multiple examples, but you can provide your own, and this is really, really good for you, because you will be able to craft your metrics, as you see fit, and you will be able to access them in Grafana automatically. So, and we will go into how Grafana is instantiated later. Okay, so let me check the time. All right, so far so good. So these are other examples of metrics that you can provide. For example, suppose that you're interested in session information and you want to know the current session count, first segment here, or you want to know the active sessions, second segment here, or you want to know the inactive sessions, third segment here. As you can see, we are providing SQL that it's tapping into the $B session view to actually extract this information. So as long as you provide the system with these metrics, you will be able to export them and see them within Grafana, okay? Now, the nice thing is that You don't have to set up anything for this to be able to run. You basically need to provide them in the place where you put the metrics, and the system will basically collect them and provide them as metrics. Okay. So enough with the metrics. Let's take a look at the other part, which is the logs. Okay. So we want to provide. We are also interested in providing SQL code that can actually provide logs, right? And with logs, we are talking about logs that can be scraped by this system. The typical logs that you can get from a database, for example, in the case of Autonomous, you could be accessing the $diag alert X, and in this case, show the context of the automatic diagnostic repository for the current container. So this is a place where you will actually go and fetch for a log. But if you have another view within the database that is providing a specific type of log that you're interested in, you can provide this type of metric here, or rather than metric, log specifically, or element, where you can and this will be picked up automatically again. So this is using Grafana Loki for the logs, which is like Prometheus, but for logs. Okay, if you're not familiar with Grafana Loki, it's very similar to Prometheus, but for logs. And Prometheus, which is an agent that sends logs to Loki, basically. So Prometheus is the glue between the database and it's working in the exporter and Grafana Loki. Okay, so in this example, as I said before, we're extracting a specific information from the automatic diagnostic repository and making it available. Okay. All right. So this is for the logs. Now let's go into tracing. Tracing is a little bit more complicated. And sorry, one sec. Okay. So with tracing, we have things that are happening at the application level. Like, for example, suppose that your application is doing a DB operation, okay? Then we have things that we need to expose with a tracing agent, so we can teach the system that something is going on at the app level, because the app is not going to magically connect to this observability system, So you need something, and that something could be, like, for example, a tracing agent that you attach to your Java process. As you can see here, the first bullet where it says tracing agent, we say attach to the app, example Java agent, DB agent, my app.jar, basically attaching it to the jar. And we need this agent to create and obtain traces, to create spans. And if you are not familiar with tracing in general, and you might be asking what spans are, basically they are representing a single logical operation within a trace. So usually reflect a specific thing, an atomic thing that's happening within a trace, and you need to be able to understand how this can maybe be aggregated on a specific operation, or how this be correlated among different elements like the app, the database, etc., etc. Okay, so we really need the support that I mentioned before, like as part of a tracing agent. And then we have the tracing exporter, which is basically querying the DB for spans, because you can send span information to the DB. For example, you could modify specific information within the DB to add span context, okay? And this is sending everything to Jaeger, as I mentioned before, which is open telemetry based and is specifically targeting traces. And this will be visualizable within Grafana, okay? And now you might wonder why all this complexity, right? Basically because we need to correlate the app to the underlying elements like the database. So we need to provide some context about what's going on here, but also we need to be able to drill down once we are within Grafana to be able to jump between what's happening with a microservice, what's happening to a specific, and what's happening to a specific database related to that microservice functionality, like an order, for example, in the order database, okay? So that's why tracing is more complicated, and it's a little bit more difficult to understand, okay? So it's very similar what we're doing in terms of the exporters. So you customize these queries to basically execute against the database. They are translated, as I said, into GLR format, and then they are pushed to Grafana. So the code, as you can see here, becomes a little bit more complicated. Here, what we want to do is to trace an order that is spanning potentially multiple sessions by user. And as you can see, the code is actually tapping to GV active session history, okay, which is a standard view. And it's using ECID and a duration window to segment the trace, okay? So in this case, as you can see, the code is a little bit more complicated, but it's basically defining a window in which we want to access this trace, an ID, which is the ICID, which allows you to correlate this between different traces, and the active sessions history to understand what's going on, what the user is doing. What is ECID? If you never heard about ECID, it's an execution context ID, okay? And it's a unique value that is assigned to each request. So it's great to correlate requests and what's going on when you want to basically do these correlations, okay? All right, so let's go into the demo right now, okay? So just a refresher, last thing I did is I set up the project. Now I'm going to do status to see what I get, okay? Okay, status, everything seems to be okay. So it's basically the same thing that I got before. Now what I'm going to do is I'm going to deploy the core services, okay? And let's see if we are in the right spot. No. So basically what I'm going to do here is I'm going to deploy the core services, and what I'm doing is I'm deploying the microservices. Remember that we have scrapped this microservices with all the database, inventory, etc., etc. We need running microservices to be able to see something within the database. Otherwise, the database is dead, okay? So let's do that. It's deployed. It's deploying a Helidon front end. So it's basically deploying the microservices, okay? So let's hope, and I finger crossed, not that this works, because I think it's going to work fine, but it doesn't take long, because I don't remember how long it takes to actually deploy the microservices. I don't think it's a long time, okay? There you go. It wasn't that painful. So if you do this, you can understand whether the last operation was successful or not. If you get 0, that means something is wrong. So let's take a look at the pods now, because remember I told you this is Kubernetes space. Okay, so just to give you an idea, these are the pods that we are running right now. You see all of them are in status running, and this is like an orchestration of multiple pods that are running right now. You can see Helidon right there. You can see the inventory service. You can even see the engines controller service, etc., etc., etc. Okay, so this is all working gracefully together, to provide you with this solution. So let's do curl pod right now, and I'm glad that this gets recorded because you can follow along later. If you're not following right now, you can watch the video again and follow. Okay, so what I'm going to do right now is I am within curl pod. And what I want to do is this gives me access to the microservices. Okay, what I want to do is just to place an order. Okay, and I'm going to place an order for sushi, and this is heavily documented in the live lab. Okay, so if you follow that short links I mentioned before, in the live lab you get step-by-step instructions. So basically in the live lab we will have to replace with your password, which is the password that you provided when you did the setup. Okay, so let's see if that already happened. I think that already happened. Okay, no, we should have gotten one second. We should have gotten like the output. Let me try again. There you go. Okay, good. Yeah, I think I was we were there. Now we have like a duplicated order with order ID, but it doesn't matter at all. Okay, so basically we have 2 orders with ID 1, and the 2 of them are sushi, but it doesn't matter. The important thing is that you get this output, where you get a signal Oh, there you go. The order is set at auto increment. So I actually get order ID number 2. So that's very good because I don't get a, a second time order ID number 1. Okay. So as long as you get that, that means that you are being able to insert an order. Okay. And this is very, very easy. It's just JSON content type, and you just add, your order. Now you probably want to query the order, right? And basically see if it's in there. So let's do that. Okay. Yep. As you can see, this is basically a way to run show order. So it's a different operation that we're running against a microservice, and we get the right result. We get sushi, right? Just right here with order ID 1. All right, perfect. All right, so with this, we just went through lab number 2 of the live lab. Remember, lab number 1 was actually the setup. Okay, so let's quickly go to lab number 3. And we are quickly running out of time here. So let's install the observability. We need to exit corpub first, sorry. So let's install the observability elements that we need. Here you can see we're installing Jaeger, we will install Grafana, we will install all the different Prometheus, all the different observability services that we need. But once we have all those elements in place, we still need the exporters, right? Remember, logs exporter, tracing exporter, et cetera, et cetera, et cetera. So we will also have, once this is done, let's wait, Grafana is being installed, to create the monitors and exporters, okay? So that's another operation that we have right there. So as you can see, I just did an install, run a script called install.sh, okay? So it's right here, in the observability directory, okay, of the project, okay. Now, Loki and Prometheus being installed. Remember, those are the things that are going to cover our logs. Okay, and we are done. Now, let's install the exporters, okay? Remember, we need metrics exporters, we need logs exporters, and we need tracing exporters. These exporters are also very versatile because you can just grab them from the code and install them in any database instance if you want, okay? All right. All right, let's wait. Okay. Now we are running out of time. I think that we will go for 5 more minutes, and then we will get until we actually deploy Grafana and configure a bit of Grafana, and then we can go into a quick Q&A session. So I deployed the exporter. Now, if I run services, you will find an external IP here. The only external IP that you will find here when you run services is right there, and you have the ingress engines controller, which is the load balancer, basically. Okay. So I'm going to type what I'm going to do. Let me see if I want to. Okay. So I'm going to type this here. I'm going to type that IP and Grafana. Okay. So Grafana, I go to the login, and here I'm going to use admin. It was admin and prom operator, which is the default. So prom minus operator. Okay. Prom minus operator. That's all documented in the. I'm not going to save. So voila, we are in Grafana. Okay. We have our Grafana up and running right now. And this Grafana is not in Grafana Cloud, it's not outside, it's within the Kubernetes infrastructure that we just shown. So it's basically, this is inside Kubernetes, okay? Now, we need to add the data sources, because this is like a, let's say, naked Grafana. So we need to add Prometheus in order to be able to scrape the metrics, or to get the metrics, right? So let's go to data source. Let me see. I can find it here. Data sources. here I'm going to type I'm going to type, click on Prometheus, and as you can see, the URL is pre-populated. You should see your URL pre-populated, okay? And now you just have to do test. It should work, and back, okay? So we have Prometheus, which is nice. Now we have all the metrics, all those metrics that I showed you, okay? Session metrics, transactional event queue metrics, etc., etc. Now we need to do the same for Jaeger, okay? So I'm going to type Jaeger here. Not sure why it's not. See, add data source here, Jaeger. Okay, there you go, Jaeger. Okay, data source added. And in this case, you need to populate the URL that's already documented in the live lab, okay? And so we put that URL. It's going to be the same URL for you, no problem. And then we click on save and test, and it should work, okay? So as you can see, it worked. And we are done with logs. We are done with traces and with the configuration of traces and metrics. Now we need to configure the logs, okay? All right, so let me go back. Let's go to add data source. In this case, we're going to add Loki. Okay, remember that we were using Loki, which is like Prometheus for logs. And we will have to populate the URL. This, okay, it's going to be the same URL for you, okay, for the whole. If you follow, the same live lab, it's going to be the same URL for you. But now we have to create a couple of derived fields, and we will end with setting up these derived fields, taking a quick look at the dashboard, and then going into Q&A, okay, because we don't have more time. But don't feel bad about this, because one of the upcoming sessions that I have, and I will allow you to vote on the upcoming session, is doing a deep dive on traces and going into the dashboard and see how we can basically analyze, the dashboard and how to take a closer look at traces, etc. But let's get to that point where we are ready to do that deep dive. Okay, so I provided this URL, and now I need to go to derived fields, click on add. I need to click on internal link. Okay, I need to select Jaeger here, not Prometheus. Okay, now for what I'm going to do is I'm going to create a derived field for the microservice log to trace correlation. So basically, how can I correlate log to a trace within microservices? Okay, so I'm going to call this trace ID from span reported. I'm going to use this regular expression for it. Okay, so what we need to do is say you get this line from the exporter. This is how you need to see it. This is how you need to extract it. This is the regular expression that you need to use to actually extract the actual value out of it. Okay, and then we need to provide this query. Okay, all right. Now, if I provide an example here, it should work. For example, I provide this, and as you can see, yeah, it's extracting. Okay, so in URL label, I don't think I have to add anything. Just I forgot, but I think we are fine for now. Okay, so we are adding another derived field right now. So let me see how can we add another one. Okay, another one. In this case, is also Jaeger. And what I'm going to add now is a second derived field, which is for database and ECID log to trace correlation. So remember that I mentioned ECIDs, how you will be able to correlate these numbers, and especially when you are going into database. So this is what we need here. And I'm going to call this trace ID from ECID. The regular expression is based on ECID, and it's going to be this, okay? And then the query is going to be value raw. Same as before. All right. And now if I use this test message, so the test message is basically giving an example of how the data will come here and what this derived field is going to do with it. Okay, so if I put this, I get this separation, of the elements, which I think is fine. Okay, value and URL. Okay, so now I have to click on save and test. Worked, and then back. Okay. Okay. Now we have set up Grafana, right? Now, but we need the dashboard. We need to visualize all of this, right? And we can really start playing once we have the dashboard. Okay. So we are going to install the grab this dashboard, and for that, the dashboard code, because you can import JSON code. If you ever create a really nice Grafana dashboard, you can export it as JSON, publish it somewhere, somebody can basically grab it. And that's how dashboards are available within Grafana too. As you can see, you can go and say, oh, I want to use this dashboard, and it's not yours, somebody else created it. Their code, basically, okay? So if you go to this URL here that I'm showing on screen, you will get the dashboard in code, right? But we need to import it, right? So let's go here and let's find the way of how we can import that content, okay? So let's see, we have dashboards, import, yeah, dashboard, import, okay? So let's import via panel JSON, okay? And I'm going to copy all of this. This is part of the project, by the way, of the Unified Observability project, it's right there inside the project, okay? And I'm going to paste it here, and I'm going to load, okay? And once I load it, as you can see, the name is grab this dash, and I click on import, okay? All right, voila, we have the dashboard right here, okay? Now, let me see. We might want to go ahead and generate, maybe we can go to the, again here, maybe we might want to insert. Let's go to, just give me 1 sec. Let's go to correlate again. Let's see if it remembers my previous commands. Oh yeah, nice. This is for sure. And we might want to insert, let's say, I don't know, what's your favorite kind of food? For me, it's chicken, okay? So let's say order ID 3. Okay, and we have inserted that. Okay, now let's go here. So as you can see, we are now getting data for CPU load. And the important thing that for you to understand right now is, first of all, before taking a look at the actual thread count, CPU load, etc., is the organization of the dashboard. As you can see, we have dashboard for the specifically for the front end microservice. It's the front end of the system. Then we have a dashboard for the order microservice and PDB, and this is using transactional event queues. Here you have PDB status is up, et cetera, et cetera. And as you can see, we have a place order count that is now being reflected, specific, information. You can always lower on a specific dashboard on a specific element here. You can do explore, et cetera, et cetera. But you can also take a look at the order PDB sessions, place order count, CPU load specifically for that microservice, heap sizes, et cetera, et cetera, et cetera. Obviously, we also do the same for the inventory microservice, right? So this is very microservice related. Okay. Now, if you go here, you can see that the event mesh is up. You can see the inventory queue here reflected. The problem is that we only have, 2 or 3 orders right now, right? But this will auto update as you have a very database and provide very valuable information. Obviously, you can provide your own metrics, as I said before, and then you can come and change this dashboard. You can tweak and create this dashboard as you see fit to reflect exactly what you want to measure, right? Let's go quickly to the presentation, just to do a final remark until we're done. Okay, so this is a wrap-up of the. Just to remind you what we just saw. We just saw this Kubernetes environment providing exporters such as tracing, metrics, and logs. We used Jaeger, Prometheus, and Loki to actually aggregate all of that into Grafana, and we show the graph and we show the dashboard in Grafana that's basically consuming from this data sources, traces, metrics, and logs. Unfortunately, as you can see, we already ran out of time. There's no time to go into tracing, which is, let's say, the most interesting part of all of this, because we can understand how we can actually correlate, information between app and database. But we can do another session related to that if you allow me. This is like a long workshop if you want. So it's not enough for 1 hour. But remember that I mentioned the Oracle operator some time ago. So this solution allows you to connect to any Oracle database, not just autonomous database. And that's thanks to the Oracle database operator. So the Oracle database operator is a project in which Oracle wants to extend the Kubernetes API with custom resources and controllers for automating the Oracle database lifecycle. And they are supporting multiple databases, even on-prem and even autonomous database, okay? And they are working, if I understood correctly, on adding observability straight into this operator. And with this operator, you are using Kubernetes, basically, Kubernetes operations, okay? So this is going to be really nice. And this is what enabled this unified observability project to actually connect to any Oracle database. So it's provided by the functionality of the Oracle database operator, if you want that. Okay, so I'm done for now. Just wanted to thank you for it. Please vote for our next session. We can, pivot and go to MongoDB API with autonomous database. If you are a MongoDB developer, we can take a look at using Oracle backend for Spring Boot, or we can do a deep dive and take exactly from this point where we have our Grafana up and running, and start playing with Grafana and start taking a look at traces, more specifically at traces, which is the most interesting part in my opinion. Okay, so thank you for that, and all yours, Sarah.
Thank you everyone so much for joining us, and we hope to see you again next time.
Yeah, please see you on the next one.